In order to add, they have to have the same exact dimensions. If you are trying to add or subtract and you have different dimensions, your answer will be undefined. And there are some on here that say undefined. And the reason they're undefined is in order to add, you have to have an element to an element. And the only way to do that is to have the same exact dimensions. So this first one is a 2 by 1, 2 rows by 1 column, 2 by 1, 2 rows by 1 column. I can add them. And the adding piece or the subtracting piece is rather simple. You add the elements. I'm going to add 4 plus -3. That will give me a 1. 6 plus -6 will give me a 0. That is my answer. So adding and subtracting, you're literally adding the elements that are inside. And the only way you can do that is if they line up. All right? For scalar multiplication, really there is no rule as far as dimensions go. You have a number on the outside, and you have whatever matrix you have. It could be just like this one, a 4 by 1, a column matrix, or it could be a 4 by 6, right? All you do is you are basically distributing that number throughout. It is a scale, and you are multiplying each one by that scale factor. So you're going to take, your answer, by the way, is going to be the same dimensions you started with. -2 times -4. Watch your positives and negatives as you do this. And that would be your answer there. So for matrix multiplication, you do rows by columns. So the first thing you have to decide is, can I multiply them? Can I multiply them? So you want to write down your dimensions. This first one is 2 rows by 3 columns. This next one is 3 rows by 2 columns. All right, so the inside numbers tell you if you can do it. Yes, 3 by 3 means I can do it. All right. 3 on the inside of those means I can do it. They have to be the same. The outside numbers tell you what it will be. Now this happens to be 2 and 2, but those do not have to be the same, okay? Those outside numbers do not have to be the same. They just tell you what your answer will be. My answer here is going to be a 2 by 2. It doesn't always have to be the same number, but the inside ones do, okay? So the insides have to be the same number. The outside tell you what your answer will be. And then we are going to just do row by column. So I am going to take my first row and I am going to multiply it by each element in my first column. So I'm going to say 2 times 1 plus 0 times -4 plus -4 times -1. All right? Once you're done with that column, you are done with that element, and you need to move to the next element, all right? So then I am going to take this same row and multiply it by the second column. So I will say 2 times -5 plus 0 times -5 plus -4 times 1. All right? Now for this one, I am out of columns, so I am done with that particular row. All right, so I'm done with this one. Okay. I am going to move on to the next row. So now I'm going to take this row and I'm going to multiply it by the first column. So I'm going to say 1 times 1 plus 4 times -4 plus 5 times -1. I am done with that column. So I'm going to take that same row and go on to my next column. And so now I'm going to say 1 times -5 plus 4 times -5 plus 5 times 1. Some things I want to point out, a quick check of, did I put these together correctly? Your first row, if you look across the rows, your first numbers will be the same. I have 2 and 2, 0 and 0, -4 and -4. All right, my second row, 1 and 1, 4 and 4, 5 and 5. All right, so when you look across the rows, your first numbers should be the same. When you look down the columns, your second numbers should be the same. 1 and 1, -4 and -4, -1 and -1, -5 and -5, -5 and -5, 1 and 1. Now I would do this as a check. I would not just do one of them and then just do the rest, because if you mess up the first one, right, then you just assume it's correct and you copy it. But when you go back and check, did I put all these together? Because there are ways to make simple mistakes. you can double check and make sure you wrote them all down correctly. At this point, we are just going to do basic algebra. We are multiplying numbers and adding them together. And they're pretty basic numbers. So I have 2 times 1 plus 0 times -4 plus -4 times -1. So my first one is 2 plus 0 plus 4, that is 6. For my next one, 2 times -5, 0 times 5, -4 times 1. So -10 plus 0 plus -4 is -14. Second row, 1 times 1 plus 4 times -4 plus 5 times -1, sorry. So -16 plus 1 plus -5 gives me -20. And then the last one, -5 times 1, 4 times -5, 5 times 1. -5 plus -20 plus 5 is -20. And I am done. You are going to look at these like any algebra equation that you're solving, okay? So I have -2 times x plus this matrix equals this matrix. When you're solving equations, you want to get rid of everything that doesn't have an x first, and then you're going to multiply or divide to get the x by itself. That's exactly what you're doing here, all right? So for this one, I have a -2, that capital X means that's a matrix, plus a matrix. So I need to subtract this matrix first. So I'm going to take this matrix here, and I'm going to subtract it from both sides of my equation. All right? And on the left-hand side, you just get, it cancels out, right? So if I have, just like any numbers, I have a matrix and I subtract it, it's going to cancel out like this. And I'm left with just this -2, capital X there, which represents the matrix. On this side, I am going to subtract. Can I? Well, yes, it's 2 by 2 and 2 by 2. So I can subtract these two matrices. So I'm going to say 14 minus 6. Then 11 minus 9. Then 3 minus 1. And then 5 minus 7. All right. And so I've gotten it over to the other side. And now I'm going to divide everything by whatever is in front of this. Now, think about this. We haven't done division, but we have done scalar multiplication. Well, if I divide by -2, that's the same thing as multiplying everything by -1/2. Or just divide everything by -2. It's the same thing, right? So if I divide 8 by -2, I get -4. If I divide by 2 by -2, 2 by -2, and -2 by -2, this is my answer for my matrix.